3 EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3CSJ in Narre Warren South. A very pleasant good evening to everybody who's tuned in tonight on this 25th of November 2022. We're broadcasting on prime frequency of 3541 kilohertz in the 80 meter amateur radio band, and simulcasting on the medium wave frequency of 1665 kilohertz in the 160 meter amateur radio band SSB, both single sideband transmissions. We're also transmitting on the Melbourne Television Digital Repeater, VK3RTV, Digital Channel 1. Very pleasant good evening to folks watching the live transmission by the digital well, this is live nevertheless, but I thought I'd just throw that in. Anyway, we're back on ATV, which is fantastic. Many thanks to Peter and to Phil, I suspect, to getting the repeater back online. The repeater has been offline for the last few weeks, so much to the tireless efforts of those chaps, we have RTV back on stream, so to speak. You can view the Melbourne Television Repeater on 445.5 megahertz using a DVB-T2 set-top box, and point your antennas towards Mount View or the Wheelers Hill Police Academy would be another excellent point. Anyway, more information about VK3RTV can be found on the webpage, vk3rtv.com, I think is the URL. But we're very pleased to be back on the digital repeater in full HD, and welcome to viewers. Hello viewers. Alright, we also have email address, so if you wish to send signal reports tonight, you can send it to vk3ekh@gmail.com, vk3ekh@gmail.com for any signal reports. We also have a Discord channel that's watching. My audio level on YouTube might be a little bit too high. I'll see if I can just knock that back a bit. Because I know that I am inclined to just clip into the distortion on the YouTube side of things, and I think I've just reduced that down a little bit, so hopefully that'll be okay elsewhere. Yes, so we have a Discord channel, so to speak. You can find that link to the Discord chat window via the ASV website at www.asv.org.au, www.asv.org.au, and look under the Radio Astronomy tab, a little pull down box, and you'll see the link to the ASV broadcast, radio broadcast page, and within that page is the link to the Discord channel. It's a little radio telescope icon. Okay, we have a short session tonight. It won't go forever. Given the amount of articles I've managed to pull down off the internet in the last hour, I've just kept it to a small theme tonight, so we'll see how we go if we don't stuff it up. Oh, nothing like your first squig of coffee. Alright, I think I've covered everything. A very pleasant good evening to Andrew and Stephen. They've just sent me a couple of emails there, I can see. VK3KIS, who's listening on 80 metres, 5 and 9 report. And also Stephen, I think it's SPX, VK3SPX. And I haven't forgotten to send you those pictures. I've been thinking about it every day this week to send you those pictures of that Philips transmitter, and as soon as I think that, it goes straight out of my mind. I've had a lot of things going on this week. We've had some very serious plumbing issues, and we had a plumber come in the last couple of days digging up half the garden to access a storm water pipe that's been blocked. and I've been actually helping him quite a bit. So the area outside the back door is a bit muddy, so to speak. So I'm actually welcoming the weather pattern for the next 24 hours. A bit of warmth and dryness. Boy, do we need it here. The Astronomical Society of Victoria was founded in 1922 and has well over 1,600 members scattered about the country and overseas. Membership of the Society, of course, is open to all persons with an interest in astronomy. The Society's objectives are to encourage the study and the practice of astronomy and to disseminate the knowledge of the science, to provide greater facilities for the practice and the study for its members. Monthly meetings are usually held on the second Wednesday of each month, except in January, which we're rapidly coming up to. The latter, January, being held on a Saturday night, so country folks can trip all the way into Melbourne to the hall there for a live sit-in. Meetings usually start at 8 p.m. on the Noggin at the Mullier Hall, National Herbarium in Burwood Avenue, Melbourne, and which isn't too far from the Shrine of Remembrance. Parking is available in Burwood Avenue, Dallas Brooks Drive and the surrounding streets. Admission is free and visitors are most welcome. You don't have to be a member of the ASV. You can easily rock up and sit in on these meetings. The endeavour is to finish at 10 o'clock on the Noggin. It's pretty much time to the minute. So there's free tea and coffee, bickies as well afterwards, and a chance to chat to folks, members of the ASV, and find out how to become a member and what's involved. That's the whole idea of the public meeting. Privileges of membership include the right to borrow books, periodicals and other publications from the extensive library located also at the Melbourne Observatory. Been there for a long time. Receipt of the ASV's magazine, Crux, containing articles, news, observing notes and the like, and the free provision of the Astronomical Yearbook, which is an annual publication the ASV produce. The access is available to telescopes on members' nights held regularly at the Melbourne Observatory and after the monthly meeting, depending on weather. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. There's also a 200mm refractor managed by the Royal Botanic Gardens and a photoheliograph also housed at the observatory and is accessible to members as well. The Society also has a number of 200mm reflectors available for short period loan, a loan scheme that ASV has going. So members can actually loan a telescope, try it out, and get a bit of a feel for what a real telescope will give you, and give you some idea about what to buy if you're interested in getting a telescope. Members are also encouraged to make use of the Society's country property located just north of Heathcote, some 90-minute drive north of Melbourne. There are a range of instruments available for members to use, with the larger two of the telescopes, optical telescopes with appropriate training, which is fairly easy, and which range from 300mm to 1000mm in aperture. Also located on the site up there is an 8.5 30 foot, which was 30 metre, 8.5 metre, 30 foot fully steerable radio telescope, which members can access with involvement with the radio astronomy section. Members are encouraged to make and use telescopes, of course. Advice and help on both matters are provided willingly to newcomers desiring to do the same sort of thing. It's quite nice if you can make up your own telescope and ground your own mirror and learn how to do all that. Instrument making is only one of the number of common interest activities catered for within the Society. In fact, there's about 20 individual sections that make up the various activity groups within the society. A handful of those is instrument making, deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet, radio astronomy, computing, cosmology and astrophysics, historical studies, research and astronomy in general, all catered for one way or another. More information about those individual sections that make up the ASV can be found on the ASV website at www.asv.org.au. Look under the sections tab, and all those 20 sections that I referred to are listed there in alphabetical order, and by clicking on the individual pages you will be taken to a separate page where information about each section will be revealed, and on most pages you'll be able to find contact details for the section directors that operate the individual sections, and by contacting them you can ask whether you can sit in on a meeting and find out whether it is your kettle of fish, and in which case you'll also be mentioned about the possibility of becoming a member. A member of the ASV is done by the homepage, and when you go to the homepage of the ASV you can see the link to membership. It's all done by PayPal, or very easy peasy Japanesey. So there it is. Contact details, as I've mentioned just now, contact details for various section directors are provided in the yearbook, but not everybody has the yearbook, so unless you remember. So again, the website is your reference for all this. Please note that the ASV, there's one more further little thing here. For further information about the ASV, of course, visit the ASV website, as I'm alluding to. Notifications of events are given in the Crux Extra bulletins. That's a special email publication which is sent out every other week, keeping members informed of what's happening, latest events, things to keep in mind, and all that sort of thing. So, and of course, also please note that the ASV will conform to all government health directives, as it has been doing. ASV events may be required to be cancelled, moved or postponed. So, information you can, if you wish to write a letter to the ASV, you can send it to the Secretary, the Astronomical Society of Victoria, GPO Box 1059, Melbourne, Australia 3001, if you wish to write a letter. Again, the website is the best place to go to at www.asv.org.au. G'day to Don, VK3HDX, has just sent me an email. Better read that just in case he's got visitors. It doesn't look like it, so there it is. I lost the opportunity. He had some visitors a few weeks ago, and I should have read out their names to say g'day, but I didn't see that part of the email, so it doesn't matter. Oh, alrighty then. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, transmitting since 1988 on these frequencies, more or less, and we're still going strong, despite the odd Friday we miss. Okay, so very pleasant good evening to Richard, VK3VRS, and Steve, VK3SPX, who are up there on the chat window. So if you wish to join the chat window, just go to the Discord chat window. Right, let's get into some of the news that I've got tonight. Let me see. We've got the, by the way, we've got the Christmas Star Party tomorrow. The Christmas Star Party is kicking off from about 3 o'clock in the afternoon tomorrow at Heathcote. For more information about the Star Party, the Christmas Star Party, just go to the ASV website and view the information that's on the screen there. There's a few things, of course, happening. And again, if you go to the ASV website, you can find out from the homepage all the information there. The ASV Starbecue is a great opportunity to see the night sky from the dark sky site. I just hope the weather stays good for them, because things are going south from tomorrow night from 6 o'clock onwards. So let's just hope that the Great Dividing Range does its job. Dear. But yeah, there's all sorts of things happening apart from the barbecue. Kids' activities all afternoon, astrophotography display in the club room. The scheduled activities are solar viewing, radio astronomy, good old wine tasting, the Lions Club barbecue, always a good one. There are site tours being conducted between 4 and 5 o'clock. Apparently we've got Santa Claus arriving sometime after 5. Then there's the Astro Trivia Quiz Bingo arrangement from 5:45 to 6:30 in the afternoon, of course. Then there's the Super Raffle Draw from 20 minutes to 7 in that time frame. It's good to be up there before all that happens. And then at 9 o'clock, you've got What's Up in the Sky Tonight. So I'm not too certain who does the What's Up in the Sky these days. Perry Vlahos used to do the Sky at Night thing, but I think there's somebody else that does that now, which is going to be held in the astrophotography field. That's interesting. And then, of course, after that, it's looking at the sky for the whole night. There'll be telescopes set up around the observation field. Usually there's anything in excess of 20 to 25 telescopes, all variety. So just roll up and talk to the people running the telescope. They'll be quite happy to let you look through the telescope and ask questions. That's what it's all about. And the astrophotography area also will have telescopes set up for astrophotography. And again, feel free to ask a couple of questions to the astrophotographers, but they'll be more than obliged to reply. And of course, go over to the radio astronomy section and give those guys a bit of a shake and ask them what it's all about. It's always very interesting what's going on over there in the RA section, and a very pleasant good evening to Phil and anybody else that might be listening at the moment. In fact, there's probably a crew up there right now listening to me in the club room. So, okay. Oh, blah, blah, blah. Okay, enough of that. Okay, tonight's got a bit of an Artemis theme. So we're just going to be going straight into Artemis. The latest on Artemis at 22 past the hour. And I've got a picture here of Artemis on its way to the moon. So let's just bring that up for you to look at while I read out a few things. And the article is, this one here's, yeah, okay. Artemis, why it may be the last mission for NASA astronauts. Artemis 1 is on its way back to Earth, successfully completing its maiden flight. In this image you're seeing on the screen right now, or YouTube, just checking the ATV repeater, in this shot, this is a camera mounted on the tip of one of the Orion capsule's solar array wings captured this footage, or picture, of the spacecraft with the moon in shot. It's quite a selfie. Neil Armstrong took his historic one small step on the moon in 1969, and just 3 years later, the last Apollo astronauts left our celestial neighbour. Since then, hundreds of astronauts have been launched into space, but mainly to the Earth-orbiting International Space Station. None has, in fact, ventured more than a few hundred kilometres from Earth. The US-led Artemis program, however, aims to return humans to the Moon this decade, with Artemis 1 on its way back to Earth as part of its first test flight going around the Moon. The most relevant differences between the Apollo era and the mid-2020s are an amazing improvement in computer power and robotics. Moreover, superpower rivalry can no longer justify massive expenditure as in the Cold War competition with the Soviet Union. In our recent book, The End of Astronauts, Donald Goldsmith and the author who wrote this that I'm reading argue that these changes weaken the case for the project. Artemis mission is using NASA's brand new space launch system, which is the most powerful rocket ever, similar in design to the Saturn V rockets that sent a dozen Apollo astronauts to the Moon. Like its predecessors, the Artemis booster combines liquid hydrogen and oxygen to create enormous lifting power before falling into the ocean, never to be used again. Each launch therefore carries an estimate cost of between $2 billion and $4 billion US dollars. This is unlike its SpaceX competitor, Starship, which enables the company to recover and reuse the first stage. So, the benefits of robotics. Advances in robotic exploration are exemplified by the suite of rovers on Mars, where Perseverance, NASA's latest prospector, can drive itself through rocky terrain with only limited guidance from Earth. Improvements in sensors and artificial intelligence will further enable the robots themselves to identify particularly interesting sites from which to gather samples to return to Earth. Within the next 1 or 2 decades, robotic exploration of the Martian surface could be almost entirely autonomous, with human presence offering little advantage. Similarly, engineering projects such as astronomers' dream of constructing a large radio telescope on the far side of the Moon, which is free of interference from Earth, no longer require human intervention. Such projects can be entirely constructed by robots. Instead of astronauts who need a well-equipped place to live, if they are required for construction purposes, robots can remain permanently at their worksite. Likewise, if mining of lunar soil or asteroids or for rare materials become economically viable, also could be done more cheaply and safely with robots. Robots could also explore Jupiter, Saturn, and their fascinatingly diverse moons with little additional expense, since journeys of several years present little more challenge to a robot than a 6-month voyage to Mars. Some of these moons could in fact harbour life in the sub-ocean surface oceans. Even if we could send humans there, it might be a bad idea, as they could contaminate these worlds with microbes from Earth. So what about managing the risks then? The Apollo astronauts were heroes. They accepted high risks and pushed technology to the limit. In comparison, short trips to the Moon in the 2020s, despite the $90 billion cost of the Artemis program, will seem almost routine. Some more ambitious, such as Mars landing, will be required to elicit Apollo-scale public enthusiasm. But such a mission, including provisions and rocketry for a return trip, could well cost NASA $1 trillion. Questionable spending when we're dealing with a climate crisis and poverty on Earth. The steep price tag is a result of safety culture developed by NASA in recent years in response to public attitudes. I'll just go back to my live camera here. This reflects the trauma and the consequent program delays that forwarded the space shuttle disasters in '86 and 2003, each of which killed the 7 civilians on board. That said, the shuttle, which had 135 launches altogether, achieved a failure rate below 2%. It would be unrealistic to expect a rate as low as this for failure of a return trip to Mars. The mission would, after all, last 2 whole years. Astronauts simply also need far more maintenance than robots. Their journeys and surface operations require air, water, food, living space, and protection against harmful radiation, especially from solar storms. Already substantial for a trip to the moon, the cost differences between human and robotic journeys would grow much larger for any long-term stay. A voyage to Mars, hundreds of times further than the moon, would not only expose astronauts to far greater risks, but also make emergency support far less feasible. Even astronaut enthusiasts accept that almost 2 decades may elapse before the first crew trip to Mars. There will certainly be thrill seekers and adventurers who would willingly accept far higher risks. Some have even signed up for the proposed one-way trip to the past. This signals a difference between the Apollo era and today, of course. The emergence of a strong private space technology sector which now embraces human spaceflight. Private sector companies are now competitive with NASA. So high risk, cut price trips to Mars, bankrolled by billionaires and private sponsors, cold be crewed by willing volunteers, ultimately the public could cheer these brave adventurers without paying for them. Given that human spaceflight beyond low orbit is highly likely to entirely transfer to private funded missions prepared to accept high risks, it is questionable whether NASA's multi-million-dollar Artemis project is a good way to spend government's money, which I guess ultimately is our money, one way or another. Artemis is ultimately more likely to be a swan song than the launch of a new Apollo era. Yes. New technologies for getting there quicker is needed. Come on, Star Trek. Sorry. All right, you're tuned to ASV, good old ASV radio, where the time is, 28 minutes to good old 11 o'clock. Now, this is an interesting little thing I've picked off the line tonight. We're going back to Artemis in a short while, but I thought I'll throw this in. G'day to Remus. I can see Remus is tuned into the chat window. And Kieran, VK3BTV, is also there too. G'day, Kieran. I'm working on setting up my own optical observatory out in the backyard. I've got a 3-metre scope dome coming on board a ship as I speak. Very expensive scope dome. But it is a once-in-a-lifetime purchase, and it is a fair, decent commitment to doing astronomy. Only those who have scope domes know what I'm talking about. But thanks to Sidereal Trading for organising that scope dome. A great group of people that run that business, and definitely looking forward to getting the scope dome out here. I've got to build a deck first. Apart from all that, one of the things that I look forward to doing with the telescopes set up that I hope to employ is looking for variable stars. I think that's a very interesting little task. And here's a little article on observing basics, how to observe variable stars. A star changing brightness is a captivating affair, and I'm looking forward to doing something along those lines. There's an image here, a star map. In fact, I'll bring up this star map. Now, the thing to be aware of, the articles that I pull down off the internet are generally American, have an American flair. So references will most likely be to the Northern Hemisphere, but let's just live with that. To estimate the changing brightness of a variable star, such as Algol, it's best to directly compare it to other nearby stars of known magnitudes, which are marked above in green, which I think you can see, you should be able to see clearly enough. The eclipse times for Algol, I think that's how you pronounce it, between late October and the end of the year are listed in the table at the right. Now, I'll show that table in a minute. But the article goes on to say that arguably, a hobby's greatest benefits is derived from its rewards. Yes, this is the author, I've been an avid backyard astronomer for 60 years. I've got a lot of catching up to do. Anyway, he says that I've been an avid backyard astronomer for 60 years. He says, I still recall the night in 1963 when my high school friend Ray Gerby showed me Saturn and its rings through his 80 times Gilbert reflecting telescope. That experience and a penchant for writing paved my way to this column, which has rewarded me countless times over the years, more on the next month. Oh, okay. As for observational aspect of backyard astronomy, no activity has rewarded me more than a variable star observing. I'm loving it already. After briefly toying with the beginner level variables like R. Leonis, I joined the American Association of Variable Star Observers, or AAVSO, in 1980. Since then, I've forwarded more than 80,000 visual brightness estimates of variable stars in this noble organisation. Each one wound up in the database that AAVSO makes available to astronomers worldwide. In other words, variable stars have rewarded me some 80,000 times over. You don't have to become an avid variable star observer like me, the author says, but if you've never witnessed a star changing brightness, I urge you to at least give it a try. The typical variable star fades from maximum to minimum brightness and back over a period of days, months, or even years. But now I'm going to introduce you to one that dims and bounces back in just a matter of hours. Moreover, it's bright enough to view with the unaided eye. Naked eye. Without further ado, our one-night variable star is eclipsing binary Algol, A-L-G-O-L, Algol, or Beta Persei. Visible as a single second magnitude star, Algol is actually a tight eclipsing binary system comprised of a hot and bright main sequence star paired with a cooler and dimmer subgiant. The two complete an orbit every 2.87 days, and because their orbits are edge-on to our line of sight, they periodically eclipse one another. A deep primary eclipse occurs when the fainter star passes in front of its brighter partner. When this happens, Algol fades from magnitude 2.1 to 3.4. The secondary eclipse is too small to detect without specialized equipment. Now, I'll just bring up this chart they've got of dates and times. This may not be exactly applicable to us down here, but it gives you an idea where the article is going. If you're up to experiencing an Algol eclipse, here's what you need to do. First, equip yourself with a clipboard, pencil, red filtered flashlight, torch, bloody flashlight, and a watch or smartphone to keep track of time. The clipboard should hold a blank sheet of paper and a copy of the Algol field chart at the left, which I think is what you're looking at the moment. Next, use the accompanying table to select a date and time for an upcoming eclipse. From beginning to end, each eclipse lasts about 10 hours. Fortunately, Algol is nearly at maximum brightness in the early and late hours of the eclipse. You'll catch most of the action by starting your observations 3 hours before mid-eclipse and continuing for another 3 hours afterward. Step outside about 10 to 15 minutes before this time to dark, adapt your eyes and familiarize yourself with the location of Algol and surrounding comparison stars. Their magnitudes are labelled in green on the Algol field chart. When ready, make an initial magnitude estimate of Algol. Simply find a nearby star that is equal brightness to Algol and jot down the time and magnitude. Don't fret over accuracy. The data you collect are for your eyes only. Your goal is simply to document the behaviour of an eclipsing variable. While most visual observers of Algol-type variables make their estimates every 10 to 15 minutes, you'll get decent results by checking in every 20 to 30 minutes. After returning indoors, graph your data using time as your x-axis and magnitude as your y-axis. When you connect these points, you will have created a light curve of Algol's eclipse. Pretty neat, huh? That's what he says here. If you only have time for a quick look, make an estimate of Algol's magnitude a few hours before a predicted minimum. Then, when it is close to its maximum brightness, repeat at the time of the mid-eclipse. You'll be amazed at the difference. If your experience with Algol piques your interest in variable stars, the author says, I encourage you to find out more about this rewarding activity. Your best source is the AAVSO website, which is www.aavso.org, where you'll find a how-to guide for beginners and a list of easy-to-observe variables. So I think that is something worth following up on. Again, when I finally get my telescopes up and running, it's just one of the things I look forward to being able to do. Because how many times can you turn a telescope to a constellation, to a globular cluster, to a deep sky object, which by eye can often be fairly faint to see, and I think with optical astronomy you really do need to expand your horizons, and I think astrophotography is the key to all that, with using an optical telescope. So I'm just saying that optical astronomy, which I'm yet to explore fully, it's its door open, and astrophotography and variable stars and comet hunting, particularly comet or asteroid hunting, is something that's also worth interesting to do. Yeah, I'm looking forward to that. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. Here's a quick little article. Rising star in astronomy. Now, I usually have trouble with names, but I'll try to get this right. It's Jeddah Isler. Jedidahisier. Jeddah Isler. Whatever. Anyway, the article goes on. It says that, or she says, I think this is a quote from her, I think one of the biggest problems we have yet to solve is how to truly make sure that the science and technology ecosystem is open, welcoming, and accessible to all. And I've got a picture of this young lady, so I'll bring her up. She's got a lovely smile. And the article goes on to say that these days, Jeddah Isler doesn't have much time to research blazars, supermassive black holes devouring material in distant galaxies, though she's still interested in how they produce their jets. Instead, in the White House Office of Science and Technology Policies, OSTP, Principal Assistant Director for Science and Society, she is working full-time on advancing equity. She says, I think one of the biggest problems we have yet to solve is how to truly make sure that science and technology ecosystem is open, welcoming, and accessible to all. She's 40 years old. She says, well, like many others, Jediah's interest in astronomy started as a young girl looking up at the night sky. I think we've all been there. I always found it to be so magnificent, she says. It made me feel full of wonder and a profound sense of connection to the universe, the people on the planet, and all the generations of civilizations that have looked up at a similar sky. She earned her bachelor's degree from Norfolk State University in Virginia and a master's from Fisk University in Nashville, Tennessee, before heading to Yale University for a doctorate. In 2014, Jediah became the first African-American woman to earn a PhD in astrophysics from Yale. She then went on to Dartmouth College in Hanover, New Hampshire, to start her own research program. Along the way, she found the non-profit STEM route to change the Search Foundation, SERCH Foundation, aimed at using science to advance social justice issues. She's also the creator and the host of Search's video series On the Vanguard, Conversations with Women of Color in STEM, and has served on the American Institute of Physics task force to elevate the representation of African Americans in undergraduate physics and astronomy, Team Up, to increase African American representation in undergraduate physics and astronomy programs. Jediah's colleagues are quick to laud both her professional accomplishments and her personal character. Equity, justice, and inclusion seem to be interwoven into the fabric of who she is, says Arlene Modest-Knowles, Team Up Diversity Task Force Project Manager, which says, I know that the work that she is doing at OSTP will have far-reaching, long-lasting outcomes. Jediah has also done a lot of really amazing work. In astrophysics, says astrophysicist Darrell Huggard at the McGill University, trying to understand how the light coming from a blazar systems can vary in time, which can tell us about how black holes eject material and also how they emit light. Despite all her accomplishments, Jediah remains humble. She says, I just love astronomy and astrophysics. She says, it's been such a passport in my life to opportunities that I may not have otherwise had. And so it's been a great privilege to be a part of the community. I hope that through my work, I can help contribute to make it even better. What I like there in that statement is it's been such a passport in my life to opportunities. And I think I think there's a message in all of that for us. A passport. You're tuned to VK3 EKH ASV Radio. Now, let's move along here. NASA's Artemis 1 launched a solar sail, CubeSat, to an asteroid, but it may be in trouble. Space.com. Now, I've got a little picture here, an artist's impression of this, so I'll just keep that up on the screen for a little while. A tiny asteroid explorer that launched on NASA's moon mission last week still hasn't phoned home. Near-Earth asteroid Scout has one of 10 CubeSats that hitched a ride to space on NASA's Artemis 1 mission, which launched on November 16. The spacecraft was designed to sail on sunlight to fly past a small asteroid dubbed 2020 GE, about a year from now. But something seems to have gone wrong after the CubeSat was deployed. Following a successful separation and deployment from NASA's Space Launch System on November 16, the Near-Earth Asteroid Scout project team has not yet established communications with the spacecraft. NASA officials wrote an email in an emailed statement. Teams continue to work to initiate contact with NEA Scout. In particular, NEA Scout personally are hoping that the spacecraft's unusual propulsion strategy could help them track down the CubeSat. Packed into a small satellite was a reflective silvery solar sail that unfolds to 924 square feet, or 86 square meters, larger than a racquetball court, according to NASA. Had everything gone smoothly, the NEA Scout planned to deploy its sail in early December. According to a NASA spokesperson, then used the solar radiation hitting it to reach the asteroid. Instead, despite not having heard from the spacecraft, NASA's personal broadcast a command for an emergency solar sail deployment twice on Monday, November 21, in hopes that the highly visible sail could help them find the CubeSat. If the spacecraft is listening and successfully opened its sail, it could be seen from telescopes on Earth. NASA's officials wrote several ground-based observatories are attempting to look for NEA Scout and share data which will be invaluable in helping determine the spacecraft's status. NEA Scout isn't the only CubeSat from the last week's Artemis 1 launch to struggle. For example, there's a Japanese lunar lander which missed its date with the moon, and another NASA CubeSat, Lunar HMAP, missed a crucial engine fire as it flew past the moon on Monday. The agency added the CubeSats to Artemis 1, knowing that the small mission carried higher risk than larger spacecraft with more redundancy and durability built into its design. Other CubeSats that launched last week seem to be doing better. An Italian CubeSat called Argo Moon is successfully sending home stunning photos of the moon and of Earth, and a second Japanese mission called Equalus reported having safely made its first lunar flyby. If NEA Scout recovers, it will be NASA's first solar sail to leave Earth's orbit if it safely reaches asteroid 2020 GE. The spacecraft will likely make the slowest asteroid flyby to date, and the asteroid will become the smallest any spacecraft has visited, according to NASA. So let's hope that works out for them very, very soon. Okay, next Artemis article. And this is a bit of an update, I suppose. Artemis 1's Flight Day 9. Orion 1 day away from distant retrograde insertion. This was published when? November 24. And there's an image here that I can crop up. It's sort of similar to the first image I put up, so I'll just run that. So there's Artemis on its way to the moon. It's one of those little selfie shots that it likes to do. Orion is now about 1 day away from entering into a distant retrograde orbit around the moon. The orbit is distant in the sense that it is a high altitude, approximately 50,000 miles from the surface of the moon. Due to the distance, the orbit is so large that it will take the spacecraft 6 days to complete half of a revolution around the moon before exiting the orbit for a return journey back to Earth. During the last day in the transit to distant retrograde orbit, flight controllers performed a third in a series of planned Star Tracker development flight tests relative to the Sun, with a fourth planned for tomorrow. Star Trackers are a navigational tool that measure the positions of stars to help the spacecraft determine its orientation. In the first 3 flight days, engineers evaluated initial data to understand Star Tracker readings correlated to thruster firings. The spacecraft completed its 6th outbound trajectory correction burn at 3:52 p.m. CST, firing the European Service Module's auxiliary engines for 17 seconds to propel the spacecraft 8.9 feet per second. This is the final trajectory correction before entering distant retrograde orbit. When in lunar orbit, Orion will perform 3 orbital maintenance burns to keep the spacecraft on course. Overnight, engineers will begin a 24-hour test of the reaction control systems engines to evaluate engine performance for standard and non-standard thruster configurations. This test will provide data to inform procedures and ensure that the reaction and control thrusters can control Orion's orientation in an alternative configuration if there is an issue with the primary configuration. So just after 1:42 p.m. CST on November 24, Orion was travelling at some miles per hour. They don't give any reference to kilometres an hour, but the Orion was travelling at 222,993 miles from Earth and 55,819 miles from the Moon, cruising at 2,610 miles per hour. NASA television coverage of the distant retrograde orbit insertion burn is scheduled for Friday, November 25. The burn is scheduled to take place at 4:52 p.m. US time somewhere. Okay, so that's the latest on Orion in that respect. But one other interesting little thing here that's come up, courtesy of the ASV's Space Exploration section operated by Kate Green. Thanks, Kate, for your continued update of the Space Exploration section. You do a great job in keeping everybody updated on the ASV's Facebook page. Really excellent. NASA loses contact with Artemis 1's spacecraft for 47 minutes. Scary stuff. November 23, NASA unexpectedly lost contact with its moon-bound Orion capsule early Wednesday morning for reasons that remain unclear, although probably by now they might have had found the reason for it. The uncrewed Orion has been performing well since launching toward the moon last Wednesday, November 16, on NASA's Artemis 1 mission, but this Wednesday, November 23, brought a blip. Mission controllers lost communication with Orion at 1:09 a.m. While reconfiguring a link between the capsule and the Deep Space Network, the set of radio dishes that NASA uses to talk to its far-flung spacecraft. The reconfiguration has been conducted successfully several times in the last few days, and the team is investigating the cause of the loss of signal, NASA officials wrote in a brief update on Wednesday. I wonder if they were using the Parkes radio telescope at that time. Anyway, joke. Anybody who's seen the dish will know what I'm talking about. Anyway, the communication outage lasted 47 minutes and Orion came out of it in good shape. The spacecraft is healthy and suffered no apparent ill effects, NASA officials said. Orion is gearing up for a crucial manoeuvre. It's scheduled to perform an engine burn on Friday, which I've just read out. The capsule will arrive here with a parachute-aided splashdown in the Pacific Ocean off California, scheduled for December 11. So there it is, 47-minute loss of signal was scary stuff. Anything could have been happening, anything. But fortunately, things are still good. Still green lights. All right, just a quick look at my windows up here. Cassiopeia, g'day Nebs, he's come in. And Kim, VK5FUSE, is also there, g'day Kim. Now, coming up to the hour, it's amazing how 1 hour I can fill in. Now, if you're not aware, there's a documentary being released and it's being screened on Prime Video. But I think you probably find it on YouTube, maybe. There's a Mars rover documentary called Good Night Oppie, now streaming on Prime Video. Good Night Oppie, or Opportunity, finally arrives on the Amazon's Prime Video streaming service, not wanting to advertise, just in time for the holiday viewing over the long Thanksgiving Day weekend, for what that's worth. Good Night Oppie is ready to roll into your home and show you just Good Night Oppie is ready to roll into your home and show you just how emotional you can get over a robot. Fresh from its theatrical release on November 4, Amazon's original film New Mars Rover documentary, Good Night Oppie finally arrives on the Prime Video service again, just in time for the holiday viewing. I've just read all that. This heartbreaking yet inspiring documentary was directed by Ryan White, or Dr. Ruth, in association with Peter Berg's Film 45 and Ambulance Television, and presents the real-life survival tale of Opportunity, NASA's legendary rover sent to Mars for a groundbreaking 90-day mission that lasted beyond all measure of hope for nearly 15 years. And there's a slide I can put up here, so I'll just run this slide. Okay, so that gives you a little bit of a... you can't really read that, but that's the slide, or the poster for the documentary. Good Night Oppie is a tribute to the indefatigable wheeled machine and its human engineers and scientists here on Earth that became deeply attached to Opportunity throughout its conceivably successful venture across the Red Planet's landscape. The Academy Award-winning actress Angela Bassett narrates Good Night Oppie, which showcases the bond forged with Steve Squires, JPL's principal investigator for the MER mission, and the entire ground team in California. It features a wealth of archival NASA footage, new interviews with the principal NASA engineers, and a brilliant CGI wizardry from the talented folks at the Industrial Light and Magic team. NASA's Mars Exploration Rover mission launched twin motors, Spirit and Opportunity, to our neighbouring planet back in 2003 for a series of geologic and atmospheric tests and experiments. Though not possessing Opportunity's incredible longevity, Spirit went on to operate for 6 years. Oppie broke all records in the collecting data and samples for 9 more years, finally giving up the ghost in June 2018. Good Night Oppie lands again on the Prime Video streaming service on November 23, so that's available to view now. Now, I can see it's already hit 11 o'clock, and I've just got a few more things that I want to roll with here. I don't think I'll worry about this video because it goes for a couple of minutes, but it's a trailer. I was just going to run a trailer for the documentary, but I think now that I've mentioned about Good Night Oppie, all you got to do is go to YouTube, type in Good Night Oppie, and you'll see the trailer that I'm talking about, and it gives you goosebumps. You want to watch it, so there it is. All right, now one last article I want to throw in here before I go to spaceweather.com. Where are we? Where is my thingy here? There it is. All right, now this is not a very big article, thank goodness, but it's interesting. This is interesting. And I thank Stuart Southam for this. Stuart's one of our members of the radio astronomy section, but Stuart sent this link a few weeks ago, in fact. It was published 15th of November on space.com, I think. Maybe not. Anyway, China's newest telescope will stare right at the sun next year. China's well and truly getting into astronomy with their massive radio telescopes that they're building. So I've got a picture of a sun here, which is part of the article, so I'll bring up that while I'll go through this. And there's one more image. Near the edge of the Tibetan plateau, Tibetan, that's it. Near the edge of the Tibetan plateau, China is currently finishing up the final construction of the Daoqing Solar Radio Telescope, a brand new Chinese solar telescope set to launch in 2024. The new telescope, which will consist of more than 300 dish-shaped antennas, cost 100 billion yen to build, or $14 million US, and will study the sun in greater detail. Now here's the image of this. It's an aerial shot of this ring of dishes. This is very much like the heliograph that was used up at the Narrabri radio astronomy site, the solar heliograph. It's a very similar concept, I think you find. What makes the new Chinese solar telescope so intriguing, aside from its size, is that China will open new doors for how we study our solar system star. And with so much information about the sun still a mystery, it's possible we could see data from the telescope causing some monumental breakthroughs in scientific field. The new telescope will join the likes of NASA's Parker Solar Probe, which previously touched the sun, as well as the European Space Agency's Solar Orbiter. The Parker Solar Probe was launched in 2018, and ESA's Solar Orbiter was launched in 2020. Together, these telescopes, as well as the new Chinese solar telescope, will give us unprecedented data about the sun. The Daoqing solar telescope, the solar radio telescope, is being constructed near the edge of the Tibetan Plateau. This telescope is launching an opportune time, as well as our sun will enter a highly active stage of its 11-year cycle within the next couple of years. As such, the Chinese radio telescope should provide a front row seat to some of the most intense solar events that we've seen in recent years, including solar flares, coronal mass ejections, and even events on the surface of the sun. Additionally, with the Chinese solar telescope, as well as Parker Solar Probe and Solar Orbiter trained on the sun, it should make it easier to predict how solar weather will approach Earth. This can help us better prepare for any issues like dangerous solar flares and more. These flares can often wreak havoc on our technology and satellites, causing crashes, issues with GPS, and more. So isn't that an amazing structure that they've got going here? Looking forward to more information coming in from this amazing telescope. All right, so talking about spaceweather.com, let's hit the weather, spaceweather.com. I'm amazed that I'm running over time here, but there it is. You're tuned to ASV Radio, VK3EKH. Okay. The solar wind is currently at 470.2 kilometers a second at a density of 11.15 protons per cubic centimeter. The current disk of the sun has 4 sunspots on the disk of the sun as we speak. They are designated as AR 3152, 3149, 3151 and 3147. The current sunspot number is 61, and the radio sun is at 110 solar flux units measured at a wavelength of 10.7 centimeters. 110 solar flux units is the current radio sun, and the planetary K index, KP, is currently equal to 4.33, which is extreme. So the planetary K index, KP figure 4.33, is currently extreme. We also have an image of the coronal sun, which is currently showing no holes. There are no significant coronal holes in the Earth side of the sun, and that's what you're seeing right now is the sun as we speak. And the auroral activity over Antarctica is currently this one. It's for those watching YouTube and the ATV repeater. That is the current coronal auroral activity over South Pole, and there is definitely a strong push towards the mainland. So there might even be a little bit of a light glow on the horizon, southern horizon. So that's quite interesting. Now, just continuing on a little bit with the solar report. Let me just bring up the camera again. bear with me a sec while I select it. I'm doing everything via vMix. Now, where's my article again? Oh yeah, there's a possible CME impact. There's a shock. There's a shock wave in the solar wind. Excuse me. Hit Earth's magnetic field today, November 25, at approximately 0230 UT. It might have been the belated arrival of a CME that left the sun on November 19, hurled in our direction by erupting filament of magnetism. So far, the weak impact has not caused a geomagnetic storm, though. But there is a possible CME impact that might occur today. And there's also another interesting thing here. There's a cryovolcanic eruption on a comet. The British Astronomical Association, BAA, is reporting that a new outburst of cryovolcanic comet 29P Schwarzmann-Watchman on November 22nd. Amateur astronomer Patrick Wiggins watched 29P increase in brightness by more than 9 magnitudes. See, this is where optical astronomy is really fascinating. You can actually see if a comet changes its magnitude if you're observing it, and in this case, this is what happened. There was a sign of a eruption was in progress, and I've got a picture of it, although it's a bit vague, but I shall just run with it. Okay, so that's the plume, so to speak. They say here that the Pac-Man shape of the ejectica, suggests that the outburst is coming from a discrete source on the comet's surface. This would fit a leading model of the comet developed by Dr. Richard Miles of the British Astronomical Association. Currently, the expanding cloud has an integrated magnitude near +11, which puts it within range of backyard telescopes. If this is anything like the past eruptions, Pac-Man should grow much bigger in the nights ahead. Monitoring is encouraged. So we're talking about comet 29P Schwarzmann and Watchman. I don't know whether that's viewable in the southern sky. You'd have to check for that. And I am going horribly over time. My apologies with this, but there's also something about Venus on the spaceweather.com, and I'll just bring that up. Okay. Full Venus on Thanksgiving. It's very American. Like the moon, Venus has its phases. On Thanksgiving, Venus was full. Okay. Venus was 99% illuminated when photographed the planet on November 24. And I don't know why it's so blurry, though. It says here that it's not easy to observe Venus when it is in full from Earth. Venus looks full only when it is on the opposite side of the Sun, as far from Earth as it can get, and surrounded by bright sunlight. Okay, with Venus only 8 degrees away from the Sun, it was a great challenge just to find its small disk against a very bright background sky, says the astronomer. But I managed to do it using a Celestron Edge 9.25 with a 2x Barlow. Well, yeah, I thought it would have been a clearer image, but there it is. Okay, fair enough. That's courtesy of spaceweather.com. So if you want to follow up on that, spaceweather.com is where you can go to read a little bit more about that. Oh, my goodness me. As of the 25th of November, there is 2,316 potentially hazardous asteroids. So there you go. All right, I'm going to leave spaceweather.com there, and we shall conclude tonight's service. So I thank you very much for watching and listening to tonight's articles. I hope you found one of those at least of some value. I thought the variable stars was an interesting one. Updating you guys on Artemis was also valuable. and particularly the Chinese Solar Radio Telescope. I'll see if I can find out more information on that as time goes by. So on that note, this is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, concluding tonight's transmission broadcast, ASV Radio, broadcasting from the studios of VK3 CSJ in Narre Warren South. Thank you for watching. I'm glad that the Melbourne television repeater is back online. Again, if you want to find out more information about VK3 RTV and how to watch it or how to view it, and it's fairly easy to do, just go to the vk3rtv.com website page, and all the information will be basically presented there, but I can certainly tell you later. So we shall conclude the transmission on our medium wave surface. So this is VK3 EKH. Thank you for listening on 160 SSB tonight. We're concluding our service right now. For more information about the ASV, go to www.asv.org.au. Please stand by. Stations on 80 metres for any callback. This is VK3 EKH concluding transmissions on 160 metres. Good evening. All right. So let me switch over the speaker. I'm still using one speaker between two radios. It's very annoying, but there it is. All right, pen and paper. Okay. Are there any stations wishing to check in to tonight's broadcast? Go ahead. This is VK3 EKH. All right, maybe the signals aren't too good tonight. VK3 BTV and VK3 SPX. Any other stations wishing to check in? Okay, good on you, Andrew. We got you. VK3 KIS. All right, so it's short and sweet tonight. That's just how I like it. Across to you there, Kieran. VK3 BTV. Trust you well. VK3 EKH.
VK3 EKH, VK3 BTV. Haven't checked in for a long time there, Clint. Sorry about that. I've been busy with other things. It's wonderful broadcast tonight. And yeah, fascinating. I was impressed that you did the whole broadcast rather than packages from the US. That was really good. And very, very, very impressed with the Artemis stuff. And isn't it amazing? They're up there with technology that's about 54 years ahead of what it was last time when I went up to the moon. And you told that on that the computing power and the optics power and the measurement capability for testing that they have is just it's mind-blowing. So hopefully they'll get some really, really good results from that. VK3 KH, VK3 BTV.
Yeah, no worries, Kieran. VK3 BTV, VK3 EKH with the HF1 and HF2 radios on the camera at the moment. So I've got the 80 meter. I've got the two Pro 3s running on the camera as I speak. Anyway, I totally agree, Karen. I think if we were going to the moon for the first time in man's history now, making an attempt to land on the moon for the first time, let's just say that the Apollo mission never occurred, and that you know, here we're doing for the first time in man's attempt to land on the moon for the first time. You know, the modern technology that we have around us right now would certainly make the journey to the moon probably no more is risky, because everything like this carries risks, big risks really. But at least the technology that we have developed now is behind those astronauts that would be going to the moon. But having said that, I mean, we're talking about I'm talking about first time trip to the moon. So assuming that we would be going to the moon for the first time now, everything's new. We don't know what would happen. We don't know. We're relying on science to get us to the moon and get us back, and the amazing engineers that work behind the whole thing. So that's all been and done. The Apollo mission has done all that for us. So now it's a slightly different arrangement, isn't it? And we don't have the Cold War aspect. We don't have the the USSR creating pressure. But now there it is. Yeah, no, it's interesting. And I'll for this Friday night thing that I do, I'll continue to try and update as we can. And if there's any new images that come through, I'll pipe them over on a Friday night if you don't get to see them through the week. Because NASA TV and at the Artemis website have all that updated, including the various Facebook pages that are covering Artemis. They all update. The people that run those Facebook pages are well and truly very good at keeping things updated. All right. Thanks, Kieran. Thanks. It's good to hear you. You're 20 over 9. Good signal indeed. Stephen, VK3SPX, VK3EKH. Have a say. Oh, that's interesting. Okay.
Looking at some more sort of scientific, citizen science type projects would be good. I had a bit of a go at exoplanet transit, and that was quite fun. There's a whole bunch of software, of course, quite apart from the astrophotography software to get your telescope tracked in the right place and keeping the objects of interest in the same place. There's quite a bit of photogrammetry software to measure apparent star magnitude and tracking them over a period of time. It's quite sophisticated, so you don't really need to the telescope and jotting down on a piece of paper what you think brightness is. You can be a lot more scientific about that, and certainly I know, at least with the exoplanets, the professional astronomers just don't have enough telescope time to do all the observing they might do because the big telescopes don't cost a lot of money. So amateurs providing additional information on exoplanet transit and the stars and what have you was quite a useful addition to the scientific knowledge. So lots of fun to look forward to there. Okay, UK3 EKH, this is UK3 SPX.
Yeah, thanks, Steve. VK3 SPX, VK3 EKH returning. Yeah, well, I agree with all those comments, and Yeah, look, I think that ultimately sending robots to the remote, distant, robotic missions. I mean, so far we've been fairly successful, providing that the engineering has been calculated to be precise and work, and no errors. Reaching planets in the solar system has been fairly successful. And if we wish to land on these other moons, I mean, we did land on, was it? Oh, I can't think of the moons now. The methane, the moon that's methane, one of the moons of Saturn, I think. Titan? I've forgotten right now. But anyway, we did land on that, fairly successful. But the probe didn't last for very long. It was just an experiment to launch a probe down to the surface and take multiple images before it kind of failed. But it basically did work. So we have to find a way of being able to travel amongst the planets, in our solar system at a much faster rate. There has to be a way of being able to move amongst our celestial bodies in a timely manner. So we're still talking about technologies, I guess, that are far off into the future. I'm sure something exists that man can use to travel beyond the stars. Anyway, that's enough of that. But I'm definitely looking forward to getting the telescope set up, and I'll keep you and everybody else informed of the progress of the local observatory. And of course, one of the things that I want to do is stick a camera on the telescope, and if I can beam real-time images off the telescope to the A2V repeater in this case, but I guess also YouTube, then that's a bit of a bonus. But all those things, variable stars and looking for asteroids and comets, I'd just love to get a comet named after me. After the observatory. The observatory will be called JB Observatory, so it'll be named after that. Anyway, enough of that. Oh, excuse me. All right. Andrew, VK3KIS, VK3EKH. Have a say, Andrew. Very weak. Okay. I think you put it back to me. Yes, sorry, Andrew.